Calculating a 95% confidence interval for number needed to treat is fairly straightforward, since number needed to treat is the inverse of the absolute risk reduction. However, the interpretation is not as straightforward. Let's take a look at that. Let's look at an example. If we see that the number needed to treat for relieving numbness in the lower extremities after 3 sections of spinal manipulation is 6, with a 95% confidence interval of 2 to 10, then we can say that our best estimate of the average number of patients who will need to be treated before seeing relief of these symptoms in one patient is 6. And we might see a benefit of the intervention is in as few as 2 patients or possibly as high as 10. So how do we calculate the confidence interval for the number needed to treat? Well, we start with the absolute risk reduction. In this case, it's 0.17 with the confidence interval ranging from 0.10 to 0.24. And what we do, we take the reciprocal of the upper and lower confidence limits for the confidence interval, and then we reverse their order. So for example, the lower confidence limit is 0.10. We invert it, and then we use that as the upper limit, so that it will become this 10. And so the number needed to treat is 6, with a confidence interval ranging from 4 to 10. Now let's look at another scenario. In this case, the absolute risk reduction contains the value of 0. Again, we repeat the process. We take the reciprocal and reverse the order. So that now -1 becomes -1, and 0.04 becomes 25. We have a very large number needed to treat, so that the treatment is not very effective. Now let's focus on the confidence interval and the estimate. The number needed to treat is 50, and the confidence interval goes from 25 to -1. Do you see anything weird about this? Well, let's look at it. It seems that 50 is outside the range of the confidence interval, and also the confidence interval looks quite weird, from 25 to -1. What we can see is that the 50 is right here, and so what we do is we have the confidence interval. We're really not thinking about it. We shouldn't be thinking as the confidence interval being from -1 to 25, as it's shown up here. This would be incorrect, but actually it does go from 25 all the way to infinite, then it kind of goes from infinite to -1. Now think about it. What would be a very bad treatment? What would be the NNT? You would have to keep treating people, and nothing happens. So a really bad NNT would be an infinite number of people that you keep treating and nothing happens, right? So the infinite is our no. Now, in this case, when you are going all the way to in this range, is really how you don't have a very good this treatment. As you keep going closer and closer to infinite, the treatment is less and less effective, to a point where it becomes harmful. So in this case, we can report, if we see a number needed to treat negative, we can report it as the number needed to harm. And this suggests that the control group has a better outcome. So how do we report this confidence interval? we can report it as the confidence interval ranging from 25 to infinite for number needed to treat, all the way to number needed to harm equal to 1. So there is a small possibility that this treatment might be harmful. So here is an example of a study that we worked on and published on a symbiotic trial to prevent sepsis among infants in rural India. I was involved with the analysis. So let's look at that. So these were the results. I know one of the things happened. I was involved after the first analysis, so I repeated the analysis. One of the things we did was to report the study using risk ratios rather than odds ratio. That is a much better measure. And the number needed to treat, we had times when like you can see in this case, for example, we did not report this when there was that problem with the confidence interval. Now, my preference would be to actually report the confidence interval exactly as shown in the previous slide rather than reporting it as NA. But that was acceptable for the journal in this case. And so here we had the primary outcome variable, which was death and sepsis together. The risk ratio was 0.6, with a confidence interval from 0.48 to 0.74. And the number needed to treat was 27, with a range from 19 to 47. This was the confidence interval. The number of deaths were very small, and you can see here there were 4 deaths in the control and 4 in the symbiotic trial. And the risk ratio here is crosses 1, which also meant that the risk difference crossed 0, and so the absolute risk reduction crossed 0, and so the number needed to treat spanned the infinite, because infinite is essentially 1 divided by 0 is infinite. So that's the reason why in this case the number needed to treat was reported as an NA. And this was again the same for the outcome, a secondary outcome of abscess and otitis media, with very small numbers. And this was the risk difference crossed 0, the risk ratio crossed 1, and the number needed to treat confidence interval was spanning infinite. And this was considered an acceptable way of reporting the result. Although, again, at this point, I will probably insist on reporting the full result still and not just NA.